We chose an optical computer mouse as a dynamic system. Our system operates with an optical light sensor. They weigh between 50 and 100 grams. To detect movement, an optical mouse uses a light source, LED or laser, a photo detector, typically a CMOS sensor, and a digital signal processor. Our governing equations of motion are law of reflection, intensity of light, and acceleration. For the acceleration equation, air and drag resistance are negligible. The force is user input based, m is the mass of the mouse, and mu underscore s is the friction of the surface being operated on. Our inputs are reflected light, electric charge slash signal, acceleration of the mouse, and human input. Our outputs are pixel location on the space screen and movement of cursor.
A mouse has a control system with a feedback loop in it since there's a use for every output with every given input, meaning that if you do an action on the mouse will recall that last output and make the new input to update the position. An example of this can be seen by moving your mouse physically. You could see that it translates to the screen. This makes the system continuous as it has to continuously keep updating it. Even once you're not moving the mouse, it's still going to keep updating. The control system runs with a MEMS micro electromechanical system accelerometer, which relates the position of the mouse's accelerometer with the screen's cursor position. The coordinate frame for the mouse is only in a two-dimensional plane, as once it's pulled into a three-dimensional plane, the readings stop. Lifting the mouse causes a lack of reflections on the sensor, which means that it can no longer detect any movement. Since there's no movement, there's no inputs. No inputs causes no outputs, which causes it just to not function.
Description of process. In order to understand how the system worked, we did some research on how the optical sensor operates within the casing in order to move the cursor on screen. It breaks down as follows. The LED light emits a color light that shines onto the surface of where the mouse is located. The light is then reflected back and picked up by the CMOS optical sensor. This sensor takes thousands of images every second, which are then sent to the DSP. The DSP analyzes the images to determine if movement occurred and in what direction and speed. This information is then sent to the computer as an electrical signal to output the cursor's position on screen. Here we have our block diagram representing the process described before. We can divide the process into three components: the inputs, the control system, and the outputs. Under the inputs, we have the electronic signal sent to the computer, as well as the acceleration of how fast the mouse and sensor were moved. This is received by the MEMS, which processes the inputs in order to determine the current position of the cursor and the direction to be moved, which then provides the new position and acceleration of the cursor. The new and current positions are fed back to the MEMS in order to know where the new start position will be. The output is the display, which is the movement of the cursor on the screen, which we are able to see and change.